So let's look at the apparatus that we'll be needing to measure the acceleration of the cart. We've got a runway, so we're going to confine the cart to one direction. There is an end brake to stop the cart flying off the end and hitting the floor. The cart obviously, and some masses to accelerate it, which we'll talk about later. A bench pulley over which the string goes that's around the cart so that the acceleration is in that direction. We're going to be using, in this case, a light gate which needs a interface to take the data. The flags we can either have two light gates and one card, or a double interrupt light and a single light gate. Either way, you're measuring velocity at 2 times. Retort stand to hold the light gate, and a set of a balance to measure the mass of these, just to confirm our values. Right, we're going to run through the method of doing this experiment. We're starting off with the lowest mass, which is half a newton, 50 grams on this mast hanger. That goes over the bench pulley. We make sure that the trolley is firmly in the channel, ready to go. We've already set this to measure acceleration based on the parameters of the light interrupt, so it needs to know the two distances and its separation. So we're ready to go. We've pressed play. We're all ready to start reading, so we'll let it go once, taking it round, twice, making sure that the mass hasn't fallen off the end, 3, 4, and a 5th run. Now if I bring the camera across to the screen, you'll see the data that we've recorded from that time, that run. So after recording the first data set, we now need to get our second data set. So I'm adding another a mass of 10 grams here, so that's 0.1 of a newton, and exactly the same as before. We start running with the interface running. We sort of have our 5 runs again. So 1, making sure it's located, 2, 3, 4, 5. Now I'm not going to stop this, I'm going to carry on and add another weight. I want to go up in 10 grams, but I'm using a 20 gram mass to replace that one of 10 grams. So that has taken us up by 20 grams, or 0.2 of a newton, and we're ready to run again. 1, 2, 3, 4, 5. And this time we're going up another 10 grams, but we've got that single 10 gram again. So I'm trying to avoid putting this through the light gate every time. 1, 2, 3, 4, 5. Now this time 10 gram comes off and then and another 20 gram goes on. All the time we're keeping the mass of the whole system the same. So we are not gaining any mass other than, but the accelerating mass has changed. 1, 2, 3, 4, 5. And finally, we're going to put the last of the masses, last of the 3 masses on here. So we're using all the accelerating masses that we have. 1, 2, 3, 4, 5. One other thing I'd like to point out is that this, when the mass hits the floor, which is just here, it's, the acceleration is beyond the light gate. The only other thing, as I said, apart from that, is we'll need to make a note of the total mass of the of everything together. So I'm switching the balance on, tearing it, or zeroing it is the normal way to say it, and then we put this on and our total mass is 611 grams.